All right, welcome back. This video is about average values of functions. There's many different ways you can calculate the average value of a function. And what I want to do is introduce this topic in the context of bank accounts and revenues and finance. Once again, one of our core areas of application for this course. We're looking at a bank account of some type. Maybe the y-axis isn't in dollars, maybe it's in trillions or billions of dollars. Doesn't matter. So we have a function r of t that's telling us how much revenue is being added as a function of time. If we wanted to know the average annual revenue between year 0 and year 10, if we wanted to know what that accumulation was, so what we would do is we would add up the total revenue from year 0 to year 10. We know how to total a rate of change. We take the integral of the rate of change from A to B, in this case from 0 to 10. That would give us the area under the curve. So we're looking for the area under this curve. That gives us the total amount. Then to average it, we would divide by the number of years. So again, integral. So find the area under that curve, divide by 10, that gives you the average. So I call it total and I call it accumulated. Accumulated just makes it clear that we're adding up the yearly revenues. We're adding up the revenue as a function of time over some time period. Now that bottom piece, the 10, that's the total amount of years that we're looking at. If we were going from year 2 to year 10, then instead of dividing by 10, we would be dividing by 8. 8 comes from 10 minus 2. Just how many total years has elapsed. If we wanted to write this expression in a compact form for an average value of a function on an interval, it's this. It's 1 over the number of years, so 1 over b minus a, multiplied by the integral from a to b of f of x dx. This is written in a variety of different ways, but I think this is the best way to have it written. It's the most compact way. So as an application, we can find the average value of the function y equals x squared from x equals 1 to x is equal to 5. So f av is equal to 1 over 5 minus 1 times integral from 1 to 5 of x squared dx. So 1 over 4 times antiderivative of x squared is 1/3 x cubed. And we are evaluating this from 1 to 5. So 1 over 12 times 5 to the 3 minus 1 to the 3. So 125 minus 1 over 12, 124 over 12. I'll divide top and bottom by 2, so 62 over 6. I'll do it again, 31 over 3 will be the answer. All right. Here's another one. Find the average value of the exponential function e to the x from 0 to 1. So f av is equal to 1 over 1 minus 0 times the integral from 0 to 1 of e to the x dx. So just 1 over 1. So just in e to the x evaluated from 0 to 1. So we have e to the 1 minus e to the 0. So e minus 1 is our answer. That's the average value of the function. I'm going to draw a quick sketch of that, just to highlight what average value means. Like, what is it that we are calculating? So we're going from 0 to 1. I want the average y value of that curve. I know the average y value is not up here, right? The average value can't be larger than all the y values that are taken. I also know it can't be down here, it can't be smaller than all the y values that are taken. It's got to be somewhere in between. It's got to be somewhere in between here and here. Somewhere between there and there. And this is saying that the average value is e minus 1. So e is 2.7. It's saying it's around 1.7. Saying it's that. That's the average value of the function. I didn't draw a very good picture, and that's why it doesn't look like it's the average value, but it would correspond to the geometric average value of that function between those endpoints. Okay, now a messier looking one, but isn't that bad. Find the average value of pi times sine of x on the interval from 0 to pi. So f_av is equal to 1 over pi minus 0 times integral from 0 to pi of pi times the sine of x. I'm going to draw a quick sketch of this. X sine of 0 is 0. 0 times pi is 0. And then sine of pi is also 0. And then sine of pi over 2 is 1. So I'm going to get a peak here of pi times 1, which is pi. So this is the graph of pi times sine of x. So looking for the average y value of the function inside that interval from 0 to pi, not 0 to 0. So looking at it, it should be around here somewhere, right? Should be in kind of the middle-ish, maybe biased towards the bottom. Maybe, I don't know, it's hard to tell, right? But this method will show us. It'll tell us what the exact answer is. So this is the integral. I'm going to bring the pi out front. Factor the constant out of the integral, pi over pi, integral from 0 to pi of sine of x dx. Now what's the antiderivative of sine? It's negative cosine, so negative cosine of x, evaluated from 0 to pi. So we get negative cosine of pi minus negative cosine of 0. Cos of pi is negative 1, so I have negative 1, so plus cos of 0 is 1, so we get 1 plus 1, I get 2. So this is what it's saying. It's saying that the average value of the function is 2. 2 is indeed less than pi, so this looks reasonable. This is matching up with what the graph is indicating. I don't want to lose sight of what we're doing when we're calculating an average value beyond the graph and beyond the formula. This is not just about turning the crank and getting a number out. This number has a meaning. When we integrate something, we are doing a type of addition. We're doing a sum. We're adding a bunch of stuff together. Go back to the earlier videos where definite integrals were introduced and look at what the motivation was for that. That we were adding up how much money was being earned. So I'll go back to that idea of money, bank accounts and stuff. If we think about a bank account, what the revenue represents one component of the rate of change of that bank account. Another component would be withdrawal or cost. So revenue is a rate of change of the bank account. When we take the antiderivative of the rate of change, we get the original function. We get the amount of money in the account. So the antiderivative from a to b of f of x dx represents how much has been accumulated between time a and time b. It tells us how much the account has grown by during that time. An accumulated amount of revenue is an amount that has already been integrated. So I'll show you exactly what I mean with an example. So Waldo's turtle diaper business has an average revenue of $2,000 between year 5 and year 10. If Waldo's accumulated revenue by year 5 was $200, what was his accumulated revenue by year 10? I'm going to use our average value formula. F average is equal to 1 over b minus a times the integral from a to b of f of x dx. I'm going to let capital F of x equal the antiderivative of little f of x dx. Then what this is going to be is 1 over b minus a times capital F of b minus capital F of a. That's how this is defined. Now for our question, we're told that the average is 2,000. We're given that as data. We're told we're going from year 5 to year 10. So 5 minus 10, or 10 minus 5, higher numbered minus lower number. And we're told not what f of b is. We're not told what f of 10 is. That's unknown. But we are told what the initial amount was, f of 5. So 2,000 is equal to 1 over 5 times f of 10 minus 200. Cross multiply by 5. So 10,000 is equal to f of 10 minus 200. And that means our accumulated amount, f of 10, is 10,200. Well, this is a reasonable answer. If this wasn't, forget we're in a calculus class. Think about this logically. $200 was in the account at the beginning. We went ahead 5 years, and in that 5-year period, our average revenue was $2,000. What should be in the account after 10 years? Well, let's take the 2,000 multiplied by 5. That's how much money we've accumulated. We've accumulated $10,000. I'm going to subtract what we started with. Or rather, when I subtract what we started with, I have to get the $10,000. So it should be $10,200. Because when I subtract the $200, that leaves me the $10,000. And then I average over the 5-year period to get the $2,000. Every time we're doing an average value calculation, we're extracting information like this type of information. It's fairly reasonable. It's fairly intuitive. It looks like extremely advanced mathematics, but it's adding. We're doing a type of adding, just in a very advanced way. This next example is the test style example that gets at the heart of what antiderivatives and average values are. I want to find the average value of g of x, which is defined as 2x plus f of x, between 3 and 10, if we're told that the antiderivative of f of x is capital F of x, and we're told that f of 3 is equal to 40 plus c, and f of 10 is equal to 12 plus c. So I'm going to write down average value formula. F average is equal to 1 over b minus a, integral from a to b of f of x, or g of x. We're looking for the average of g, so this is g average. G of x dx. So 1 over 10 minus 3, integral from 3 to 10 of 2x plus f of x dx. Now I'm going to split that up, integral of two functions added together. 1 over 7, integral from 3 to 10 of 2x plus 1 over 7 integral from 3 to 10 of f of x dx. Antiderivative of 2x is x squared. We're going to evaluate this from 3 to 10. The second part, antiderivative of f of x, we're told, is capital F of x. This is capital F of x evaluated from 3 to 10. Okay, so 1 over 7 times 10 squared minus 1 over 7 times 3 squared plus 1 over 7 times f of 10 minus f of 3. So I get 100 over 7 minus 9 over 7 plus f of 10, we're told, is 12 plus c. F of 3, we're told, is 40 plus c. And we can simplify. So 1 over 7 of 91 plus 1 over 7. The c's cancel. We get negative, let's see, negative 28. So 1 over 7 times 91 minus 28. 1 over 7, 91 minus 8. So 83 minus 20, 63. 63 over 7 is 9. So that's the average value of the function g of x from x equals 3 to x is equal to 10. We had to use the definition of the antiderivative. We're told that the antiderivative of little f of x is capital F of x. And then we had to evaluate it on the bounds. We also needed to split up our integral into two integrals, not splitting on the bounds of integration, but just splitting with the usual, the integral of two things. The integral of a plus b is the integral of a plus the integral of b. So it's a question that summarizes a lot of stuff. See you next time.